So we're done with SSAS, MDX and SSRS. Last video, I think you covered the video in which we discussed about deployment, snapshot reporting and different report managing stuff, report manager related stuff of SSRS. Now the remaining concepts, that is SQL Server Advanced Concepts and SSIS. So first we have to cover SQL Server Advanced Concepts. So we're jumping back to SQL Server. And after finishing this, I think this may take some 6 to 7 or something, 8 days to cover the complete advanced concepts of SQL Server. And don't expect me to cover DBA related stuff and data modeling. I'm going to cover what are all the things that are required for an MSBI developer. So after finishing this, we will jump into SSIS concepts, our last challenge. Okay, I can directly jump into advanced concepts. I'm pretty sure that most of you guys don't remember what I have covered as part of SQL Server Basics. If I ask you this question, I covered some 60 to 70 different points, but I'll get only 10 hardly from you guys. So I suggest you guys to go to SQL Server videos once again, or else this one will be like an alien to you. You can't understand what's happening and what I'm explaining. So better, I suggest you guys to go through the SQL Server videos once again. So I'm taking AdventureWorks database, AdventureWorks DW, and let me start with the select statement. Generally, what all classes present in a select statement? Let me write a simple select statement. Select star from dim product where color in, I'm taking two colors, black comma blue, group by color having count of star greater than 500 and finally order by, let's say, color. So this is a group by statement. I've written a group by statement and the spelling of the black is not correct. It's K, and select star from dim product, and you can see I've taken group by. So what I have to do? That should be in select list, and the remaining column should be aggregating columns. Like I'm taking count of star, the number of records per each color, or which will give you the number of products for each color. I'll take it as count. Records count, let's say. Okay. Now, if you see the query, statistically or syntactical, the first thing that will be executed is select statement, that is select class. This is very important to understand. That's why I'm saying you. I'm explaining you this. First one that is gonna execute. Syntactical. The first one is select class, and the next one is from class, and the third one is where class, and the fourth one is group by class, fifth one is having, sixth one is order by. So if you see the syntax, this is how the flow will be. Select, from, where, group by, having and order. But execution wise or logical query processing, if you consider that, the flow will be like this. The first one will be from class. The second one will be where class. Third one will be group by class. Fourth one will be having class, and fifth one will be the select class, and sixth one will be the order class. Let's take this query. If I execute this, it is giving me some data. There is no color count. This is too good. The count is 500. This is why it is not getting. Let's say I'll give it as, let me give 10 each product. Yeah, blue color products are 28 and black color products are 133. So if you see the query, what people will think is, okay, it will take these two first, and then it will go to the table name and get the data and so on. if you see the query wise. But actually what's happening is first it will go to the from class. It will take the data from this table. And then it will apply the where condition to the data and filter this data. And then the output of the data after applying the where will be applied with the group by color. It will take only black and blue color products and it will group by this color, and it will check the having count of 10 greater than 10. So count of star, that means count of records greater than 10. And then it will go back and it will get, okay, what are all the things he's asking for? He's asking for count and color. So it will get these two and then it will order based on the color. So this is how the query flows if you go for logical query processing. And the from class, now let's see each and every class, what is the use of every class. And you are very well aware the select statement is used to query the data. Query the data from a table or more than one table, right? Generally what happens if you add a select statement? It's not only query. First it queries the data and it manipulates the data. Manipulation means this group bys and all those stuff is manipulating. It is not the data, direct data that is being pulled from the database. It's a manipulated data. And then it will return the result set. It has these three steps. One is query, second one is manipulate, and the third one is result set, returning the result set. So all these classes plays its part in executing the select statement or in returning the result set. So let's start with the from class. What from class will do? From class will describe from where the data needs to be queried. Let's say if you specify from dim product, in this case, that means the query needs to be processed from dim product. And sometimes the table names looks like this. From sales dot dim product. What does this mean? What is the meaning of this? Let's see whether we have anything like that. If I go to the tables, you can see everything is dbo dot, dbo dot, dbo dot, and so on. So everything is default database object schema. If I give something like this sales dot dim product, that means this table is having a schema called sales. So it's a container. A schema is like a container or a bucket into which you can add tables. So for example, let's see how to create a schema first. Create schema and name of the schema. Let's say sales. Sales looks fine. So if I execute this, it completed successfully. Now, how to add a table to this? Let's see how to add a table to this. Create table sales.test ID integer name varchar of 10. So if I execute this particular syntax, this particular query, it executed successfully. Now this is the table name and this is the schema name. The schema I created. Schema is nothing but a container. For example, all employee related stuff will be under schema, like employee schema will be created, and the table names like employee details, designation details, and the department details, and leave details, and so on. So they will categorize into one schema, and the finance related tables into finance schema. They will create one schema and they will have all the data into one schema. The advantage of this one is you don't need to, I will tell you the advantage. Before going to that, let's see how to query this. Select star from test. To execute this, there is no object called test. So how you have to call when you have a schema defined for a table? You have to call with schema. Sales is the schema name and dot test is the table name. So this is how you have to call a table which is added to a particular schema. So let me tell you, schema is like a bucket. Let's say you have a one bucket, let's say sales, and you can add some 10 to 15 tables. The advantage is if you want to provide access to these 10 tables for a particular user, if you provide to schema, that is enough. Instead of going to each and every table and provide the access to each and every table that belongs to employee or that belongs to finance or that belongs to IT and so on, You can define one schema, add all the tables to the schema, and give or deny access to the particular schema. So that is the advantage of schema. You can either grant or deny access to a particular user for the particular schema, which will make all the tables that are present in the schema available or hidden to the particular user. So adding and providing access or denying access, it's all in the hands of DBAs. It's the job of DBA. But just to give you some idea, I explained you a little bit about the schemas. Why? Because most of the cases if you work in real-time projects, then you will find table names like the sales dot fact internet sales. So you should not get confused. What is this sales and what is this fact internet sales? So just to give you that idea, I've spent little time on this schemas. And you can alter the schema. Alter schema, let's say sales, and I'll say transfer dbo dot dim product. So if I execute this, the command executed successfully. Now let me go and execute this query. It is saying invalid object dim product. This is about schema. Now there is no project table called dim product. Why? Because I have transferred this dim product table from default DBO schema to sales schema. So this is how you can move the tables. Now let me refresh this tables list. You come to know the magic. You can see instead of DBO, it has become sales.dim product. So this is about schemas. Schemas really helpful. If you provide or deny access to this particular schema, then all the tables that are present in the schema will be accessible to the particular user or will be hidden from the user to whom you denied the access. So this is the advantage of schema. And let's go back to the classes now. From class is just to access tables. Now this from class will become from sales dot. Why? Because this table is moved to sales schema. You can see the data coming correctly. Okay. And the next one is where class. You are very well aware of this. And before going to that, before going to the where class, let's have a little discussion on how to drop a schema. How to delete a schema, how to drop a schema. So it's like dropping a table. Drop schema, and what is the schema name? If I execute this, it will say some error like you cannot drop this, man. You have a couple of tables in this. The first thing you have to do is you have to drop those tables. So what are the tables that I have? Drop table sales.test is the first table I have to drop. This is dropped. And I don't want to drop dim product. So what I will do is I will move it to DBO schema from sales schema. And I'm taking the reverse process from sales to DBO. I've moved this. Now let me refresh and see. You can see dim product has come here and it is into DBO schema. Now there is no table with the schema sales. I can drop it now. So this is about schemas, a beautiful option that is available in SSAS. So SQL Server, which you can make use of. And now let's see what is the where class do. What where class will do. Generally, it filters the data. So the where class is used to filter the data, and the group by class is used to group by the stuff. And I explained a lot about this group by in my earlier session. So just go through that once again. I'm just refreshing your minds. About the knowledge on SQL Server. Okay. And this group by class will group by the data. For example, if you have 100 records with the country name India, if you group by country, then it will become one record. The only prerequisite is whenever you select any non-aggregating column, that should be in the group by, and the remaining column should be aggregating columns like count, sum, average, min, max, and so on. So this is about group by. And this having is used to filter the data. But the only difference is between the where and having is where is applied before group by condition, and having will be applied after group by condition. So that means if you see here, where color in black and blue, that means first it filter and get only black and blue colors, and then it will group by that black and blue color, and then it will check, okay man, I group by black and blue, and what is the count? If the count is very less, then don't bring it. That means it is not at all a good product for me or good color for me. So I'm checking some condition again, and these conditions will be applied on mostly generally people mostly applies on aggregating columns, or even you can apply on non-aggregating columns, like having color is equal to black. If you provide that, it will take black and blue here in the where condition, it will apply the group by, and then it will filter the black color, and it will show you that if I provide having color is equal to black. So this having and where condition, the major difference is the first one, the where condition applies before applying the group by, and having is after applying group by. That means having applied on aggregated data or group data, I can say, and where applies on free data, that is general data that is present in the SQL Server table. And you are very well aware of this select class. What select class will do? Whatever the columns that are given here, it will be fetched. There is the select class. And the final one, order by, you can use this order by class to order the state, order the stuff. Now, let me take this query. I'm going to the new window, and I'm taking this one out, the group by condition also out. Okay. And let me remove this one too. Let me execute this. There is no sales schema now, so that is why it is throwing error. So this is the color, and let me take star all the records. So let me see all the data that is present in the table, and I have lot of data like product keys, product alternate keys, and let me go back to the colors. Okay, let me demonstrate a simple case statement. I just want to explain case statement too, which will be very useful in your real-time programming. So for that, I need a good table. I'm searching for the table here. So dim product category may be the best one. If you see, you have a different product category keys. I'll search this. Product category key, comma, English product category name. I'm getting only these two columns from this table. I have 1, 2, 3, 4 and bikes, components, clothing, and accessories. So if you, how the case statement will work? Case statement will take one input value and it will replace it if it finds that value. For example, case when product some column name is equal to something, then do something else or multiply with something else, something like that. Again, the case when statement will start. When column is equal to some value, then provide some other value. So it will check for condition and it will replace the value with the other one. For example, in this case product key is the case. When 1, then Rupesh. And I'll repeat the same. When 2, when 3, when 4, I'm giving for each and every value. Lokesh. Let me finish the syntax and then we can see the complete case statement. I've written a simple case statement, okay, and I'm replacing with this query. And let's see first by executing it and what it is going to return. So now let me explain. The case statement works like this. It will take one value, case, this is the value. The value is the product key value. Whatever the product key value, it will take that one as input, okay. and let me execute this. And it will take this one as input and checks when the value is 1. Yes, it is 1. Then show Rupesh instead of this. When 2, then show some name LOESK. And when 3, then show this. When 4, then show this and end it. Or you can provide one else part. Else all the cases apart from these 4 values, if it is anything else, show dummy guy. It will show as dummy guy. So this case statement will work in such a way that it will take the value that is provided in the case and it will check the values. It will take the column and it will check with the values whether it has that value or not. If it has, then it will show the particular value that is given or corresponding value that is given for each when keyword. So this is how, and you can see the column name is not there. So what I can do, I can provide an alias column like new name. You can see this column name is new name. 1 has become Rupesh, 4 has become Rupe, 3 has become Roesh, and 2 has become Lois. So this is how you can make use of case statements to show some other value if it is evaluated to something. For example, when 1, instead of string, you can do like this. 1 into 1000. If it is 1, then make it 1 into 1000. If it is 2, then make it 2 into 750. You can have some calculations also. It is not mandatory that you have to go for, if it is 3, then 3 into 500. Let's say you are giving some percentage to each and every guy, and if it is top ranker, give 1000, and if it is second ranker, give 750, third ranker, give 500, and if it is fourth ranker, give 100 times of the 4. So I'm removing the end part. Now if I execute this, you can see the values are getting changed. So you can have any column, any calculation here, and you can change the column value based on the case that you are providing or based on the value that is providing to the case column. So this is how you can make use of the case statements in SQL Server. Now let's revisit joins once. Why? Because we're going to use these joins very frequently in coming sessions. So I just want to brush up the concepts again. So joins, generally how many types of joins we have? Cross join, inner and outer. So generally these 3 types of joins that are present in SQL Server. So the cross join, what it will do? Cascading product. You know, the first table rows into second table rows. And inner join, first it will do Cascadian product, and also it filters. I'll explain you that. And the third one, Cascadian, and it filters, and finally it adds outer table values. So it will do 3 things. The first one, cross join, will do only Cascadian products, and inner join Cascadian product, and also it filters, and outer join Cascadian product, it filters, and also it adds outer table values. Let's see one by one. Let's take the first one, that is cross join. So how to define cross join? Let's say select star from dim product. Okay. How to use cross join? Simple. By using the keyword cross join, let's say fact internet sales. So the first table is having something around 600 records, and the second table is having something around 60,000 records. So the Cascadian product will be too high. So this is not the best table to go for. So let me change this table. I'll take dim product category, which has only 4 records. 4 into 600, it will be 2424, something around. So Cascadian product means the first table, first record will be joined with all the records in the second table. In the same way, second record with the all records of the second table. Like that, this is called Cascadian product. And there is one more way to represent the same, the cross join, that is without using the keyword, you can simply specify comma. So that table, comma, this table, then it will apply the Cascadian product. you can see the same output is coming. Both are one and the same. So the syntax, the first one using the cross join keyword and the using the comma separator, both acts as one and the same, and there is no performance difference and no logic difference. Both operate in the same way and the performance will be the same. The only thing is the syntax will be varied. This is the old syntax, the earlier one, and this is the next generated one, the latest one compared to the second one. So this is how you can go for cross join. And how to cross join same products? Let's say this one. How to cross join same products like dim product twice or dim product subcategory twice. Instead of dim product, both are dim product subcategory. What will happen? It will say you are using same table man in both the join part. I mean left hand side and the right hand side of the join. So what you can do, you can create alias for each thing. So if you create alias, then it treats as a different table. I have 4 records, 4 into 4, 16 records is the output. So it will treat this one as a new table and this one as a new table. Why? Because I have aliased the tables. This is how you can go for self cross join. We call it as self cross join. Now, I've seen it somewhere. One of the funniest join for adding the digits. This looks funny for me. When I was browsing internet, I love to browse articles, and when I was going through some article, I found this one, and this is very interesting for me. So I just want to demonstrate the same using cross join. Create table. I'm creating a table test. I'm creating an ID integer. That's it. I don't have anything else. I just have one column. Now what I'm doing here is I'm inserting values. Insert into test values. The first value is 0, and I can give by giving comma. So what will happen is it will take this many number of values. So you don't need to repeat the same query again and again. This is one way. If you have very less number of columns, if you want to pass more values like this, generally what you will do, you will write so many queries, right? So many insert statements. Instead of that, you can use like this. A single insert statement for inserting more than one record. So this is one way. Keep in mind. So what I've done is insert into test table name test values. 0 is one record, 1 is one record, 2 is one record, 3 is one record, and so on. You can see 10 records inserted. So let me check the same. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm gonna join this table 3 times. T1 cross join test as T2. I'm creating alias again, and again cross join test as T3. I've joined it 3 times. Observe this very carefully, and it is cross join. So what will be the output? Oh, sorry, by mistake I pressed properties window. So let me go to this, and if you see 3 different IDs, and it is 1000 times. So 10 into 10 into 10. What will be the output? It will be 1000. Now you can play with it. So what I'm gonna do here is I'm creating a column T3 from the T3 table dot ID into 100 plus T2 dot ID into 10 plus T1 dot ID plus 1 as value. Let's see what will happen if I execute this query. Something is wrong. Let me check this. What is the problem here? It is adding 1. So this is how you have to give T1 value into 100 3 value into 10 and 2 value into plus 1. If you see, it starts from 0 to, I think it will end at 1000 or 999. Or if you give it as plus, it will be different value, I guess. Let me see what will happen if I give plus. So I found it interesting getting the values from 0 to or 1 to 1000. If you see, these values will be 1 to 1000. In the same way, you can go for, if you have one more cross join, you may go for 10,000, and if you have one more cross join, you can go for 1 lakh. But there are many ways to get this, but this looks, using cross joins, I found it's funny. So I just demonstrated the same. So this is how cross join works. It's a cascading product. Next one is inner join. What is meant by inner join? The inner join, it will do cascading product and then filters. What it is going to filter? Let me take, select, start from dim product, inner join, fact internet sales on dim product dot product key is equal to fact internet sales dot product key. Now what will happen is it will do cascading product between these two tables now, that is dim product and fact internet sales, and then it will check the condition product key should be same in dim product table and fact internet table. So that is why I've given inner join is nothing but cascading product and then filter. The filter part is, this is the filter part, the on condition, whatever we have given is the filter part. The same query can be written without using the inner join keyword. Let's see how to write that. So this is the same query. Let me hide this window, properties window. I don't need it. Hide, fine. And let me hide this one too. You can see the dim product table, and without using keyword, that is inner join, you can use like this. But this on will not work. So you're saying these two should be joined. Where? So this guy will do the cascading product and this guy will apply the condition. So either that or this will do the same job. If I execute this guy, you can see it will return the same number of records. And among these two, which one is safe? Which one is best? My vote goes to the first one, this guy. Why? Because if I forget this condition, it will say, man, you have done a mistake. There is an error in it. If I execute this, it will say, there is an error in it, incorrect syntax. And if you miss this condition here, in this way, it won't throw error. It will do cascading product. It will do cross join. We don't know until we get the error or until someone raises that, man, you are getting wrong data, you are getting junk data. We don't understand. So it's always safe to go for the first one, that is using inner join keyword, which will throw error if you forget to add the condition part. And more joins are there, which is not into picture, like not cross joins and nothing. So there is something called composite join. So what is the difference between normal join and the composite join is? So this is a normal join, right? This is a normal join. Here you are using only one column. Let me copy it properly. You are using only one column in the on condition, right? And if you have one more condition like and dim product dot some class is equal to fact internet sales dot class or some other, sorry guys, I'm not on the track. So fact internet sales dot some column name, let's say class or currency something. So if you have more than one condition, the first condition is it is checking for product and the second condition is it is checking for class or something else. So this has more than one condition. So these kind of joins, people call it as composite joins, but which is not an official one. So you have composite conditions, so people call it as composite joins, and this is called as composite join just because having more than one column as key, primary key column, and using the same in the foreign key reference, and such kind of columns are called composite primary keys in other words composite keys, and whenever you are using such kind of condition in the joins, then we call it as composite join. So this composite join is nothing but the normal join where you will have more than one condition to be checked after the cascading product is done. And you know this is equi-join, and this is this join is called inner join, or also we call it as equi-join, right? If you see, if you take this guy, this is checking where product key is equal to key, and you are getting some records. So this is called equi-join. And if you give something else apart from equal to, let's say not equal to, this is called non-equi-join. Or you can give less than or greater than, whatever you wish to. So all these things will fall into non-equi-join. When you pass equal to, then we call it as equi-join, and if it is anything apart from non-equal to, then we call it as non-equi-join. And when you have more joins in one query, then we call it as multiple joined query. For example, this guy has joined dim product join with fact internet sales, and dim product also joins with dim product category subcategory on dim product dot product subcategory key is equal to dim product subcategory dot product subcategory key. So this is how you have more than one join. See, this guy is having inner join and this guy is having inner join. When you have more joins in a single query, we call it as multi-join query. So this is about inner joins and equi, non-equi, and composite joins, and how to write inner joins in multiple ways and so on. And the last one for today's session is outer join. Outer join, as you all know, it has three different types. One is left outer, one is right outer, and third one is full outer join. The left outer join will, what it will do? First, it will take a cascading product, and then it will filter the data, and then it will get the left hand side table products. So for example, let me take this guy up to here, and instead of inner, if I give left outer join or left join, so first it will do cascading product between dim product and fact internet sales, and then it will filter this data, that is dim product or product key is equal to fact internet sales dot product key, and then it is left join, so it will get the left hand side table and it will fetch all the extra records that is not present in the right hand side table. So it will also be shown in the result set. In the same way, if you go for right outer join, first it will do the cascading product of these two tables, and then it will filter the result set with this, and then it will get the right hand side extra records. If there is any extra records which is not having mapping key column, that is this condition column in the left hand side table, then it will pull that records, it will be shown in the result set. And if you give it as full outer join, what it will do is it will do the cascading product, it will filter the data, and it will get the left hand side extra records and right hand side extra records and show in the result set. So this is about different joins that are available, and to give you more picture, we have not discussed this much in the earlier session. So to cover out all the missed out concepts, I covered this stuff today. And that's it for today's session, and in tomorrow's session we are going to discuss about subqueries and different objects of the SQL Server. Thank you guys.